Well, it's getting kind of sad because we're approaching the end of our derivative rules. There's still more rules out there, but we're starting to run low. So today we're going to take a look at exponential function and logarithmic functions. And I'm going to give you kind of several different looks at the rules, but I'm going to give you the most useful rule here in the beginning. These are so easy. If you have the natural log function, the derivative is just 1 over the inner guts. If there was a taco, if it said natural log of taco, your derivative would be 1 over taco. And even easier, y equals e to the x has a derivative that is e to the x. The derivative is the same thing as the function. Crazy, huh? We're going to spice those rules up later. So let's take a look at two of these examples using a ninja chain rule in it. Y equals the natural log of cosine of x. The rule says just go 1 over whatever the inner guts was. The inner guts was cosine, so there it is. And hopefully your brain is trained to see layers. There's a cosine living inside the natural log, so we tack on the derivative. By the way, if I rewrite this, it looks like that. And holy cow, sine of x over cosine of x is the tangent function. Are you telling me negative tangent of x is the derivative of that? Weird. Now let's look at this one. Y equals e to the 4x times sine x. Sorry, resolution probably not so good. That's 4x times sine of x, which, by the way, I would notice right away that that's product rule. And this is an e to the something. This is a layers problem. It's another ninja. There's a 4x sine of x living inside of an e to the x. The rule says just rewrite the function and you have the derivative. So I take the function and I rewrite it. Then the other thing I have to remember is this thing was living inside of e to the x. So this entire piece is the ninja. Side note about algebra, if I wouldn't put the parentheses around that whole ninja, it would change things because I have to multiply by the whole ninja, and it's two terms connected by addition. So be careful there. By the way, I didn't write it, but I talked about it. That was also the ninja. The basic rules are really easy. The two problems I selected include a ninja, so I'm going to advance those rules a little bit and take a look at this. Based on the problems we just did, the rule for a natural log of something is 1 over the inner guts times the ninja. The rule for e to the u is e to the u times the ninja. So this would be a spiced up version of the rules I showed you in the beginning, accounting for the ninja. There it is. And we're going to do a final spiciness version. Now this is going to seem over the top, but take a look and you'll see what it's doing. And I'll also tell you that this is very rarely used, not never, but rarely. So I have log base a. Notice before, in the other part of this video, I use natural log of x, which, as you recall from your pre-calculus days, is really log base e of x. So log base e is so popular, it gets its own nickname or abbreviation, which is natural log. But the real rule for exponential functions says, hey, we know that's not always going to be an e, so here it says log base a of something. So here's the rule that you would see in the textbook. 1 over the inner guts times the natural log of that base. This is base a, so we do natural log of a. If this was base 7, we would do natural log of 7, then times the ninja. So 1 over the inner guts still is the main idea, but we have an add-on and we always have to think of the ninja. This is like e to the x, but know that it doesn't always have to be e to the x. Why couldn't it be 7 to the x or 3 to the x? It doesn't have to be e, which is 2.7. So the rule is rewrite the function. The new part, take the natural log of that base, so natural log of a, times the ninja. So now let's put these into action. These are the real rules you would see in the textbook, not the shortcuts from the other side. Log base 5 of 4x, 1 over the inner guts, natural log of the base, times the ninja. This was not something we did on the other side, or the other part of the video, because we would always have an e there. This is an exponential. 7 to the blah blah blah. Rewrite it. The derivative is 7 to the blah 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 times the natural log of that base, and then the ninja. All right, so a base that is not e is going to be rare. I'm not going to say never, but most often you're going to have e to the x style functions and natural log of x style functions, which is really log base e. So why would I show you this rule? I showed you the real rule because, well, number one, that's the real calculus, so I'm supposed to. Number two, there is a small chance that you run across non-e based functions. But watch this neat thing. I'm going to use the official rule and not the shortcuts I showed you on the beginning part of the video. But I'm going to use the same problems from the beginning part of the video. We had natural log of cosine of x as one of our very first problems on the video. I'm going to rewrite that as log base e of cosine of x, and now I'm going to use the real rule from up above. 1 over the inner guts times the natural log of the base, that's that part that we added on from the real rule. Well, the base is e, so I do natural log of e, and then times the ninja. When we did this on the other side, we didn't know about the natural log of the base, so we didn't do it. So why did it work? Here's why. The natural log of e is 1. So cosine of x times 1 is just cosine of x. So this part ends up being a nuisance if we're in base e, and so we skip it. If we're not in base e, like in this problem, you better not skip it because you'll be wrong. Okay, let's look at this rule with the addition of the natural log. And this is the same problem we did early on in the video when we were learning e to the blah blah blah. We said the rule for e to the blah 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 was write e to the blah 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 and then do the ninja. But the real rule in your calculus book says you also must take that base and take the natural log of the base. Well, once again, like in the previous example, natural log of e is a 1, so this little add-on, when we're in base e, doesn't matter because it turns out to be a 1, so that's why we skip it. These two items end up equaling 1, which makes using the real rule not necessary when we're in a log base e form, when we're in or an e to the x form. Anytime we're not in e to the x, you have to rely on that rule. So my advice, learn these rules, always be ready for the ninja, but also know that this is the real rule and you may be called upon every once in a while to use it.